We will shift focus now to thermoplastics that are commonly used in additive manufacturing. The first example we'll look at are polyamides. One example of that class is a nylon 11. The number 11 itself refers to the number of carbon atoms. Rilson is a brand name that nylon 11 is commonly available in the market, and Arkema is the company that offers that. Nylon 12 also follows the same category. Here there are 12 carbon atoms as opposed to 11 over here, and that makes it 12 as opposed to 11. Polyamide, so this is the amide repeat unit in both cases that defines the class of polymers. Nylon 12 is known as a Westamid brand that is manufactured and marketed by Evonik Industries. The two websites that are provided will give you more information about various attributes of these two materials, but generally these are high polymers that are semi-crystalline because of a large hydrocarbon component. They are hydrophobic, absorb very little water. They are also resistant to a lot of solvents. Okay, so they can be used in applications that come in contact with many fluids. They have low creep behavior and have high impact resistance, so can make rugged items. So used in household goods, automotive applications, and tubing that involves fluids as examples. The next polymer that we will look at is PEEK, polyether ether ketone, going by this chemical structure over here. These two groups are the two ethers, and this group over here is the ketone group. Cataspire is the trade name for the PEEK materials and manufactured by Solvay Chemical. The presence of benzene rings typically increases thermal stability, these structures over here. So these are capable of continuous use temperatures up to 240 C, among the highest for polymers. They have very high specific strength and modulus. Relative to their density, their strength is very high. They also have a very high chemical resistance. One of the notable attributes of this material is their inertness in a biomedical environment. It does not display any toxicity to the cells. It does not react with them in any particular way either. These attributes, so it makes PEEK very useful for medical applications. This is a spinal fusion implant. Here is a cranial implant serving as a stable, non-reactive, non-toxic material. These are usually a very good starting point with PEEK grade materials. Because of their strength and chemical resistance, can also be used for automotive and aerospace applications as well as for fluid handling. This website will give you more information about PEEK materials. The third material that we'll be looking at is ABS, which is a copolymer of acrylonitrile, which is polyethylene where one of the hydrogen atoms replaced by cyanogroup. Styrene is second monomer where one of the hydrogen atoms in polyethylene is replaced by the benzene ring. And butadiene, which is a rubbery phase, is the third material, ABS. Toyolac is a trade name. Basically, this is a thermoplastic with very good impact resistance and toughness. Lego blocks are made of ABS, and that's a very common application that it's well known for. But in general, wherever you see impact, golf club heads, protective headgear, things that shouldn't break easily, such as kitchen appliances or toys, these are all very good applications of ABS. So this website gives you more information about the Toyolac grade of resins made by Thermoplastics. A common thermoplastic that's used as filaments is polycaprolactone, a polyester effect. This is the ester group, and Kappa is a trade name provided by Perstorp. One of the distinguishing characteristics of PCl is that it's biodegradable and completely resorbable thermoplastic. So it's used for applications where it is an implant but something that disappears within the body once the wound has been healed. Another aspect is that it's made from a renewable source. Unlike petrochemicals, it has a relatively low melting point and so is processed at much lower temperatures. While its melting point is low, the strength at room temperature is quite good. So it's used for a number of applications. Typically, it is looked as a strong candidate for a lot of medical applications. Here's a tracheal tube. Here are some cell growth scaffolds, some cell growth media containers as well. Many customized applications that are possible in the medical field using 3D printing. The website below gives you more information about the PCL material. Polylactic acid, somewhat related to polycaprolactone in that it also has this ester group and so it's a polyester. NGO by NatureWorks is the brand name. Again, this is made from a renewable resource. It's a biodegradable thermoplastic, but the degradation rates are much slower than that for polycaprolactone. It has very good mechanical strength and it has good barrier properties. It's used in a number of applications. It is particularly common for filament-based 3D printing methods. NatureWorksLLC.com gives you more information about PLA. Polyphenylene sulfide, PPS, also known as Fortron, provided by Celanese, is another high temperature polymer just like PEEK that we saw earlier. Very high stability, very high chemical resistance, good mechanical properties, also flame retardant attributes, used in a powder form for powder bed processes that we'll see more of during lecture 3 in this module, used for a number of automotive and aerospace applications. These are common application areas that a design engineer can take advantage of in terms of the property window that is distinguishing for PPS. The website below gives you more information